Welcome to math class. We are covering Math Makes Sense 9, lesson 2.2, particularly covering powers of 10 and the zero exponent. So let's get going. We're going to start off with powers of 10. You'll have to excuse me if my voice sounds a little froggy today. I think I got a little bug in the throat. So open up to page 58. And what you'll see is a table there. What they want you to do is, let's just pick for a second an exponent between 1 and 5. Let's pretend we picked 4. So what we're going to do is we are going to rewrite 10 to the power of 4 as both a repeated multiplication and as a standard form. So what we get is, if we take our base number and we multiply it 4 times, so 10 times 10 times 10 times 10, we wind up with, sorry, excuse me, 1, 2, 3, 4 zeros, 10,000. Okay. Happen to notice a very simple and very easy pattern? That's the exponent, 4 zeros. So go ahead and fill in that chart on your own on page 58. Take a look at it and see. You can keep turning over to page 59, and there's another table there that shows how those numbers decrease. But for now, we're going to stick around and looking at that. And we're actually going to look at a quick example. Sorry. On page 61, question 8a. Let me scroll my screen down all the way here. So 8a on question 61, just so you get an example of how to do this. So we look at 10 to the power of 7. So first, if it's easiest, we write it as repeated multiplication. 10 times 10 times 10. And we get, oh, excuse me. All right. 10 million. Sorry, my throat's killing me. We wound up with 10 million. Okay. Or 1, 3, 4, 5, 6, and 7 zeros going on there, which makes it easier to count. You can always put the commas in for the digits there. So that's how we solve powers of 10. Write it out as repeated multiplication, and you're going to get a number in standard form. So let's move on. But if you look at back to page 59, we deal with exponent 0. For some reason, it always tends to be the scariest exponent that people run into, which is silly because it's always the easiest to solve. So in order to show you why it's easiest to solve, we're actually going to back up a step. So we look at that chart on page 59. Following the handy-dandy rules we just learned, we see that 100 is the same as 10 squared. 10 is the same as 10 to the power of 1. But what happens if we continued, and we also saw up here that 1,000 was, 10 cubed. God, my messaging's ready. My writing is messy today. Apparently my bad is talking too. So if we follow this logical chart, 3, 2, 1, 0. 10 to the power of 0. But we also have another logical step over here. We have 1, 2, 3 zeros, power 3, 1, 2 zeros, power 2, 1 0, power of 1. If we have 0 over here, and we have logically 0 zeros over here, what are we left with? Just the 1. So exponent 0, while it sometimes looks scary, is actually the simplest one. It's a really easy rule. Looking at the bottom of page 59, you can see in the examples there that all numbers with the power 0 equal 1. Doesn't matter, negative sign, positive sign, whatever it is. Sorry, it does matter, positive sign, equal sign. Question B, because we have to remember too that our brackets are going to matter. Negative 40 is a lot closer or more similar to negative 4 to the power of 0. Instead of the opposite where we have negative, 4 to the power of 0. Each of those is going to give us a very different answer. Okay. But all numbers equal 1. Okay, to the power of 0. So if we have one where we have negative 4, 0, we're going to pretend that that's just like the 4 and the 0 are in brackets. So what we actually wind up with is negative, oops, went a little bit crazy with the marker there. What we actually equal is negative 1, which then winds up being negative 1. Conversely, or opposite, felt like using big words today, if I have negative 4 to the 0, that's saying that the whole number is, including the negative, is to the 0. And as we know over here, all numbers to the 0, or to the power of 0, sorry, are going to equal 1. Okay. That's probably the trickiest and single hardest thing about dealing with exponents, zeros. Generally, you're going to wind up with stuff a little bit simpler. We're going to do a quick example from page 61 together. So you can take a look at 4a. Oops, keep getting too far down there. So question 61, or sorry, page 61, question 4a, 50 to the power of 0. Oh, big scary number, 50. I don't know what to do with that. It's easy. All numbers to the power of 0 equal 1. Okay, go ahead and try the rest of question 4 like that, and try question 5. That becomes a little bit trickier with the negatives, but you should be able to figure it out. Okay, nice and easy. So, but at what point is that going to help us with some real numbers? Well, this is a really, really important mental math skill. Being able to write or understand any number as a power of 10. So let's take the number they use in the textbook. Excuse me, sorry about that. So what we have to remember is that each of these actually has a place value. So this is the thousands, this is the hundreds, okay, this is the tens, and this is the ones. So if we have to break a number down, we can actually break it down into multiplication steps based off of our powers of 10. So looking on page 60, we go back to that same number. I'm actually going to write this one on here. So 3452. Okay. So what I look at first is I'm going to take my biggest number, the 3 over here. I'm going to look at the place value. So 3 is actually, it would be really easy to rewrite this equation as 3,000 plus 452. It's still the same number. But we can actually take that a whole step further. And we can write it as 3,000 plus, whoop, let's go back to the right color here. 3,000 plus 400 plus 50 plus 2. Now that we look at those numbers are a lot easier to work with our fancy schmancy new powers of 10 skills that we just learned. So we can actually rewrite all of these as a standard form number. 3 times 1,000 plus 4 times 100 plus 5, getting ahead of myself here, 5 times 10 to the 1 plus 2. Okay. And as we already learned before, we can actually rewrite all of these numbers. Oops, sorry, 5 times 10. I might have given you a hint already over here. I can rewrite all of those numbers as our powers of 10. I can actually rewrite this as 3 times 10 to the 3 plus 4 times 10 to the 2 plus 5 times 10 to the 1 plus 2. Okay. So that's how we can take a number and break it down into standard form.